All right, next up, please welcome Tyler Tracy for How to Build AGI.
Very important word as we, oh yeah, here. Is this one? All right, can you guys hear me? All right, okay, now you can hear me. All right, hey everyone, I'm Tyler Tracy. I am a software engineer at SupplyPike, but I recently quit and I'm moving to Berkeley for the summer and I will be doing AI research and how to build AGI safely, basically. And yeah, I also host the NWA AI Meetup. It's a great local group where we all come together and talk about AI. And a lot of the ideas I'll be discussing here, we discuss there as well. You should check it out. I won't be running it this summer, but I have some other people who will be. Okay. And another clear thing is the title was how to build AGI on the slides or on the thing. But it's very important that we have the word safety there, and you'll see why. And one more thing is, I do not want to be talking the whole time, I guess. If you have any questions, please just shout them or just raise your hand and I'll point it out anywhere during the talk when I get to a stopping point. And yeah, so let's go ahead. So, let's see, does this work? How do I use this? Okay. I guess I'll just use this. Oh, okay. Thank you. Give a round of applause for the IT guy. Here. Oh, I need to plug that in. I see. Well, we got a Mac, so we don't got a USB-C or USB-A. Wait, there's one right here. No, that's HDMI. So sorry. All right. I'm going to go ahead and start while we're waiting. And I'll be standing over here. So, oh, thank you. Okay, we got something. Yeah. Well, okay, I think you got the thing. We'll allow that. You're downloading malware on my computer now, I'm assuming. All right. Okay, let's just see. Does this work? Yes, perfect. Okay, so quick overview of the talk. There's 3 phases to it. And I'm going to give a short overview. First part of it is AGI is possible. I'm going to define AGI and kind of go over what I think it means and how we're going to discuss it. Second part, the more scary part, is AGI by default will be trying to kill all humans. We do not want this to happen, so we are going to try to build AGI that does not kill all humans. This is hard, but I think it is possible. And so we're going to be going over methods and ways of trying to do this throughout the talk. First part of this is AGI is possible. I'd like someone to throw out a definition of what they think AGI is before I start. Just whoever wants, just shout it out. I'll repeat it up here for the recording. What does it mean to you when you hear that word?
Artificial General Intelligence.
Yes, that is what AGI stands for. I should have said that. Great. Anything else? Anyone have? Thinks like a human. Okay. Any other? Skynet. All right. Perfect. Okay. So the definition I'm going to be using is AGI is a system that matches or surpasses human capabilities across a wide range of cognitive tasks. So there's some important words here. Matches or surpasses. This means it's as good or better than humans at a lot of tasks. And when I say a lot of tasks, I mean enough tasks to be generally useful in the economy. It can maybe replace some people or make a certain person a 10x, 100x type of developer. And this is not all capabilities. For example, our modern day AI systems are much better at us than chess, but maybe not much better at programming, although that is changing rather quickly. And I say cognitive tasks here, not obviously ChatGPT cannot cook you breakfast, but it can tell you how to cook breakfast. So this is cognitive tasks. But once we do hook these things up to robots, maybe they will. So this is what I'll be using. So let me tell you a simple example of why I think AGI is possible. I fundamentally believe, and I think that you should too, that the universe is fundamentally computational. This means that everything that the universe does can be represented on a computer. We build particle simulations to simulate quantum mechanics on modern day computers, and it works out pretty well, even though there's an exponential speed up. And so I do not think that there's anything going on in the brain that cannot be represented on a computer. If you do think that, then we can maybe talk about the philosophy, but I really think that there is nothing really special. This is how a neuron fires. It is very easy to replicate this on a computer. This is where we got the modern idea of machine learning and neural nets, is that we have these action potentials that fire, and that's why we have certain activation functions that mimic this. Obviously, there's a bit more going on in the brain that neural nets are not simulating entirely, but it does not seem like they're doing something that's like spooky or like cannot be represented by a computer. So if we were able to take an entire brain and simulate it on a computer, we would have AGI. That's one assertion of why I think AGI is possible. I think the modern day ways we're building AGI are going to be much, much simpler to do than simulating a whole computer. And and we can go into why. So another reason I think AGI is possible, and probably going to be here soon, is there's this concept called the bitter lesson by Rich Sutton. He's a famous RL researcher. And what he said is that the two methods that historically have been shown for building intelligent systems that seem to scale arbitrarily are search and learning. What does this mean? So historically, we've seen a lot of people in AI trying to put human cognition into the system and try to. Did you have a question? Sorry.
Yeah, you said RL, so what's that?
Oh, sorry. RL is reinforcement learning. We won't be going into RL, but reinforcement learning is a type of way of it's really useful for robotics, things that are operating in the real world. Yes, so the two types of systems that actually work, or the two methods that work, are search and learning. Historically, AI researchers have been trying to put inside of the system human capabilities and say oh, well, humans think like this, so the machine must think like this. We try to do, for image classification, we try to identify edges for it and do all this other stuff. But it seems like the things that have been working the most are where the humans just kind of give up. They throw a lot of compute at it, a lot of data at it, and they have a general architecture that knows how to learn well. And this has worked very well. This is maybe why why people would say the deep learning revolution happened in 2012. AlexNet was a system that was really, really good at classifying images, and how they did it is a rather simple CNN type of architecture, but they just threw a bunch of data at it and a bunch of compute, and it worked. And I have seen no reason that this will not continue to work. I really think that AGI can be built just by getting a bunch of data, a bunch of compute, no special algorithms, just the current things that we have, throw it in a neural net, and it will work. And then we'll have things that are as smart as us. This is probably not the way we're going to do it, but this is a possible way. Okay. This is a scary graph. I'm not going to go over all of it, but these are called the scaling laws. This is a thing that DeepMind found, I think 2019, called the chinchilla scaling laws. And what they show is that the more, there is an actual trend that as we put more compute and more data into a system, the loss goes down on the transformer, like these predicting the next token kind of things. So what is a loss? It just means how good are you at predicting the next token? So GPT-3, they put X amount of compute and X amount of data, and it was pretty good. They doubled it or tripled it or whatever for GPT-4, and it got this much better. And this seems to follow a linear trend. And they discovered this in 2019, and this has basically been holding ever since. So while I cannot tell you what it means to be able to be really, really good at predicting the next token, I can tell you that as we put more data into it or more compute in it, we will be better at this. And GPT-4 had some emergent capabilities that just came from being able to predict the next token. And so GPT-5, 6, 7, being much, much better at that probably does that. And just to give you an idea of why predicting the next token kind of means intelligence, Ilya Sutskever, someone who used to be at OpenAI, said, to predict the next token, you must predict the world in which that token makes sense. So it's not just predicting a token, it's predicting a universe and trying to figure out which token makes that universe make sense. You can imagine the entirety of a Sherlock Holmes novel given to GPT-4, and then at the very end it says, and the murderer is blank. And it's what token does it predict? It's got to figure out, do a lot of complicated reasoning to figure out who killed the guy or something. So predicting the next token, I think, is actually a complicated thing. And as it goes down, I think we will get more models, or more intelligent models. All right, so another thing I hear a lot of people say of why AGI won't happen is these things don't understand. I would argue that no one understands what the word understanding means. This is not a formal concept. It's it kind of gets in the way, I think sometimes, but we kind of mean that it gets it. It doesn't mess up in weird ways or something. But I really don't think this is a useful thing. There's no numbers that we can assign to the concept of understanding. I think a better concept is capabilities. What are these models capable of right now? What can they do? And that is just a much clearer thing that we can measure and see that they are getting better over time. This graph shows the capabilities of models over time on this thing called the MMLU. It's got its problems, but it's a big data set of language questions that are about science, math, politics, chemistry, a bunch of different things, and just you give it to the model and you ask it, and there's multiple choice, and it's got to give you the answer. And then, so this graph, I won't go over all of it, but it's kind of showing that in April 2022, we were kind of bad. As time goes on, we are getting progressively better at the MMLU. We are getting better at question answering. And this is a capability. I can say that it understands these questions more because it's doing better on it. So when we talk about what can a model do, we should talk about what can we test it, and it's getting high performance on. I will say that an average human on the MMLU gets a 90%, and Claude 3 Opus is slightly above 90%. So we are to the point where it seems like it maybe understands better than us in some domains, not all domains though. Okay, so this is another reason why I think AGI is possible. So this is just another concept I kind of wanted to talk about. Superintelligence. So this is higher than AGI. A superintelligence would be something that is smarter than us in all possible domains. Something that it can take actions that given humans would look at those actions for years and not be able to know what is going on. They are able to do just massive amounts of computation. There's no reason to think that the humans are as smart as things can get. In some ways, we're the dumbest possible thing that can build a civilization. So I think that there is no reason to think that maybe even something with the amount of parameters as a brain could be 10 times as smart. And yeah, so superintelligence, this is a good book by Nick Bostrom where he goes over all the different types of arguments of why superintelligences are possible, might develop, and why ultimately we should maybe be scared of them. Yeah, so next step, we're gonna go into the crux of the argument. AGI might kill all humans. This is a bad outcome. We really don't want this. And kind of my purpose of giving this talk is to inform all of you that this is a problem and don't listen to people who say it isn't, and kind of give you a framework for thinking about it, and hopefully give you some tools that if you do build AGI systems in the future, how to make sure that you maintain safety when you're building these. All right, so we'll go into it. So I'm gonna give a basic overview of my argument, then I'm gonna go more in depth into it. So first step is AGIs are alien brains that are trained to look nice but not to be nice. So I think that makes sense. We're asking them to do something for us, and they are making it look like they're doing this for us. But this by no means that they are actually nice. They are powerful enough to kill all humans, and they will be trying to. This is another point I will go into more, but if this is true, we really don't want this to be true. So we want to be able to mitigate against this. And despite this, we are incentivized to build these systems. This is the scary part. If it was just these two, we'd be okay, well, that's fine. I guess we just won't build them. But there are reasons that we are going to be building these nonetheless. So we need to figure out how to build them safely. Right? So I'm going to break this up into a three-part argument. So in crime and legal law, we talk about motive, means, and opportunity. So I'm assuming that AGI is going to kill all humans in 10 years, and we're going to talk about the motive, means, and opportunity that it had. So we talk about this so we can try to understand the psychology of this situation and try to prevent it. So the first thing we're going to talk about is the motive, and this one I called "That's Not What I Meant." There's a classic example of genies. Whenever you ask a genie a question, or ask it to do something for you, it always there's many examples in literature where it just messes it up, and I didn't really mean exactly that. So you could say, "Make me a sandwich," and it turns you into a sandwich. That's not what you meant by the rules. And so for the same reason, we can kind of think that AGIs who don't share any of our moral systems or any of our shared context might mess up this same thing. All of our wants are underspecified. There's many different ways that I could tell you I want to make humans happy, and you could go run with that and have a lot of different interpretations of that. So this is we need to be very specific, and it's very hard to be specific about our wants. Here's a good example. There's this effect called, there's a law called Goodhart's law. And it basically states that when a measure becomes a metric, it ceases to be a good measure. That's kind of a complicated way of saying it, but we'll go into it. So let's imagine that, or this isn't imagine, in around 1900s, the British army was in India, and there was a lot of cobras. So they were like, okay, we want to get rid of the cobras. So what are we going to do? We are going to try to get rid of the cobras, and how we're going to measure if we're getting rid of them is we're going to measure by the number of cobra heads that people bring us, and we'll pay people to like chop off cobra heads and bring them to us or whatever and get money. So this is maybe a great strategy for getting rid of cobras in the plan. What actually happened? Well, people started breeding cobras to get more heads and bring them to there to get more money. So here's a great example of something where you try to measure, are you doing something, and you have an opposite effect. And there's like a lot of reasons to think this is a very similar thing that we would have with AGI. We measure it, but it's like doing something very opposite. Like another good example is like students taking tests. Students are not optimized to learn, or not trying to optimize to learn the material. They're pushed, incentivized to do good on the test. But like the tests are supposed to see if you did well on the material. And like this is a deep, fundamental flaw, which is in measuring things. How do you measure if something is doing good? And this is how we build AGI. We measure, are you doing good, and we give a reward. So it is like likely to see that these things will not land on the goals that we want. All right? So instrumental goals. So this is the idea. Okay, so we don't really know what goal it's going to land on, but can we try to like make some arguments about the types of goals it would land on? All right, so like let's imagine we give our AGI system these 3 goals: solve world hunger, go to Mars, cure cancer, just big, giant things. Okay, well, you might reason that, okay, to do these, like all 3 of these goals, there's a common thing I need to do. I need to stay alive. If I'm not alive, this AGI system, if I'm not alive, then I can't help you go to Mars. I can't cure cancer, and I can't solve world hunger because I'm not there to change it. So how do I stay alive? Well, I need to remove things that can hurt me. You know, you don't want to have like competition or like things that could potentially turn you off. And what are the types of things that can turn you off? Well, humans can turn you off, so you might as well get rid of them before you like achieve your goal. So the hard part here is when you say cure cancer, like you might have been underspecifying, and like a way to cure cancer is to get rid of people with cancer. You know, there's like it's very hard to specify exactly what you mean. This is kind of a toy example, but we could go much deeper into this of like why sometimes you ask to do something and you get something that looks like it's right, but it's actually very wrong. And this is the instrumental reasoning to think that like a lot of different types of goals that these systems have, if they explicitly don't understand what humans are, and they're not trying to keep us alive, they might all end up on getting rid of us. Like I think a good example of this is like, even though we didn't care about like monkeys or like a lot of different like species out there, we're really smart and we're just doing our own thing with the world. And then they kind of just go away because like we're affecting the world. And we have these like much bigger systems running around. You might think that a similar thing might happen to us, and we really don't want that. Okay. So another reason like someone would say this isn't a problem is kind of as you get smarter, you'll learn to be nice. It's kind of the general thing. These AGI systems are going to get smart, and they're going to know what we want, and they're going to do it, so it's going to be fine. I think this is a really flawed argument because intelligence does not mean morality, and that's kind of the orthogonality. It's intelligence and morality are orthogonal. So an example here is, let's say so we're going to say morality goals. They're kind of interchangeable in this setting. But like we say that's the chess bot. I think his name is Martin. He's him and Stockfish, they're really, really good chess bot, have the exact same goal, but they have different levels of intelligence. So like they have the same, like they're trying to do the same thing, but they have different levels of intelligence. For humans, you know, you can imagine a human that is really, really smart, but is like trying to do good with the world, or a really, really smart human that's trying to do bad with the world. I think Ted Bundy was a good example. He worked on topology and wrote a lot of different mathematical papers about it, but he still ended up, you know, trying to kill a lot of people. So there's no reason to think that as these systems get smarter, they will like care about us. Now, they might know what we want, but they won't care about what we want. Ted Bundy might knew that people didn't want to die, but he didn't care. And we don't have any reason to think that these AGI systems will as well. So we want to prevent this. Okay, next slide. Okay, so that was the motives. I'm going to go into the means. So like, how would it do it? I don't think you need to be that creative to like think of ways that you can take out the human race. And so we want to like protect these at all cost. I think like there are human ways, like how can humans kill humans? Nukes, you know, just war in general would be like good examples of just like ways attack vectors it might go after, try to hack into these types of systems, like pit human versus human, and try to wipe us out so it can do its own thing. Then we can think of these super intelligent ways. These are harder to imagine, but like definitely possible. You can imagine technology. We don't know a lot about it, but it seems like it is possible, and it might be happening soon. And something that was able to do a large amount of research could maybe figure out how to do nanotechnology, and there's a lot of different ways you can exploit that to wipe out the world. And the same thing with engineered pandemics. You can imagine with COVID-19 that it's much, much worse, much longer dormant period, a lot more lethal, and that it was able to do it just mails it to some guy, and says put this in the water supply or I'll do something really bad to your family, and then it does it. So it doesn't seem like, you don't need to be too imaginative to know of ways that this will happen. I think I want to go into a more specific example, which is hacking. If you are in the security industry, you know that if you ever have an EC2 instance or some server, it's always getting hit trying to do automated hacking things. They're always checking your ports, seeing if you accidentally left your SSH open. And you can imagine that as we get these AGI systems, they are going to be doing this on a much larger scale. Any exploit that is possible, you can imagine these could exploit it a lot cheaper than a human and in an automated fashion. So this is I think the most immediate risk that we're going to see in the next 2 to 5 years is we're going to have a lot of automated hacking attempts on large scales. Obviously, this helps the blue team too. The defense is going to be easier. But me as a solo dev, putting up my EC2 instance just to serve something, if they're this could find a 0-day or something and be able to take down my services. So this is probably, and this is how you would imagine they would hack into nuclear facilities or anything like that. So we do not want to give these systems the means, but alas, we still might. So here's the opportunity part of this. So there is an incentive that all systems, all companies have to still build AGI, even though they know this. I took this poster from the Three Body Problem. We're going to advance, stop at nothing to advance. We want to push the progress forward. And there's capitalistic incentives to do this. You make it the company that gets AGI first will be a multi-trillion-dollar company, or probably bigger than that. So they have a lot of force to push them to get there, even though they know about the safety issues. And it's kind of a tragedy of the commons. Whoever focuses on safety and tries to make sure their models aren't taking over will be shipping slower. They will have their models be less powerful than the ones who don't. And so you can see that there is a large incentive to go as fast as you can to build these. And even though everyone might not want to, it's still going to happen. There's very similar analogies in climate change. If everyone could just sit down at a table and be oh, we can reduce our emissions, then it'd be fine. But sometimes it's well, if he doesn't do it, I'm not going to do it, and kind of thing. So this suggests that you need some kind of legislative structure. I don't know exactly what that looks like. That's not my area of expertise. But you can imagine this. And the last point is when people used to theorize about this in 2010s or whatever, how are we going to control AGI? It was well, we can't give them any tools, because we can't give them access to the real world. Well, that was kind of blown out the window because, all these ChatGPT have plugins, they have access to the internet, they can automatically code, they can, hit APIs and services, and this is a very scary thing, and it seems likely that we're going to continue to give these systems access to more tools. Just because that's of economic benefit. So these are the 3 reasons why I think AGI might happen pretty soon, or why it will be trying to kill us, and these are the ways that we need to watch out, and these are the things we're going to pay attention to. All right, so despite all this, we are still going to be building AGI, and we need to know how to do it without us all dying. So if you know my past talks I've done, they've been kind of pessimistic. I've normally ended it right before this, but this, I've been studying this, and I want to bring to you the modern day research and how people are actually thinking about this right now. It won't be a collective, a single story. I'll show a lot of different examples of different ways we can do this. But these are the type of methods to pay attention to. So we're going to start with a simple example. You're accessing GPT-4. Let's say this gray box is some guy's company. This is OpenAI. This is whatever. And you are a customer, and you're accessing it, and you go into the company, and you go back out. Whatever. This is a kind of a boring example. There's not much here, going on. So we'll expand it a bit. So this is basically a very crude setup of how we can imagine OpenAI right now, or something like Gemini, something. You access GPT-4. GPT-4 can add output actions to access the browser, access a code, run code, get the result, look at it all. Maybe you can make requests to your Google account, your Microsoft account to get certain amounts of data. And bring it together. and give you the most useful answer. This would be a great product, and this is what is going to be selling in the next coming years. This is like the basic idea. You're going to have a central model that's like agentic, it's on an agentic loop, and it accesses all these tools. Now, if we replace this GPT-4 with GPT-7, something that costs like maybe $10 trillion to train, and you just replace it, this is the kind of thing that will end up in our doom. You are not monitoring this thing, it's going to be able to automatically code, find exploits to servers, go and get data from Google, email people, this is just a terrible practice to have no type of monitoring on this. So we're going to talk about one method of monitoring. This is the trusted, untrusted model. So what we can do is we're going to assume we have an untrusted model and a trusted model. The untrusted model, for example, here is going to be GPT-4. Let's say we can't trust it. I think we can, but let's say we can't right now. And then the trusted model is going to be GPT 3.5. So what you do is every single request that goes into this model is trying to kill you. So you do not want to let it do whatever. You want to have all requests be monitored by a third party or another model that is different than this one. So GPT-3 would read all queries that you send to it, and all queries GPT-4 sends to you, and tries to parse out if there's anything malicious going on. Same thing with the code. GPT-4 is trying to, hack the server, give you exploitable code, but the trusted model is trying to flag that. Same thing with the browser, and we could go on to this. So there's two main methods you could do this: monitoring and just flagging when something bad happens and sending that to users. Your question.
So really quickly,
Yeah.
the powerful ones, the trusted ones, the smaller ones.
Yes.
Would the untrusted be aware its queries are rejected?
Yeah, I think it really depends on the setup. Yeah.
It seems like it's like having me play basketball with a 5-year-old. Why wouldn't the really smart untrusted model figure out a way to?
Yes, this is a great question, and next slide we'll talk about this. But I think this is a great intuition to have. Okay, we have this untrusted model. It's a lot smarter than these trusted models, so it seems like it can easily get past it. So this is where this is an empirical question. We could run these kind of experiments, and they did. So what we do is we do this control strategy where we have GPT-3 rewrite code for GPT-4, try to find exploits and whatever, and we imagine a red team, blue team setup where we try to make GPT-4 output exploits, and GPT-3 is trying to find the exploits. And we can see here we have a trust or a usefulness safety trade-off. So as the model gets better, obviously we want something up in the top corner. Oh, does this have a laser? Oh, yeah. We want something up in the top corner, where it is as capable as GPT-4, but as safe as, GPT-3. We don't quite get that, but we have a lot of different methods of doing this. You can just have GPT-3 monitoring. GPT-3 rewrites the top 2% of, bad-looking code or something. And, sometimes you even, would defer to a human. If GPT-3 doesn't really know what's going on, it will defer to a human. And very importantly, GPT-4 is unaware of all of this. We do not want it to be backpropping on this kind of thing. We do not want it to be learning how to get past it. But it still might be. So we have to assume that GPT-4 is trying to kill you, and that's why we do these kind of models. But this gives good reason to think that this is possible. It worked with code. There's some preliminary research that I've been looking into that is working on the same thing with bash commands. You give GPT-4 access to a terminal, it can write whatever it wants, and then your GPT-3 is watching all scripts that go to that terminal and making sure that they are safe. This seems to be a good method. Now, the hard part is okay, GPT-6 versus GPT-3, probably not. GPT-6 probably could find some really clever exploits that GPT-3 won't catch. So we need to be, there's a cap. There's a model size cap that we're once we have an untrusted model that's too big, we just can't use it. We need, and this sounds like a bad thing, but I'm going to explain why I think that we can do a lot of stuff with just slightly less than human powerful intelligences. All right, does that help you answer the question?
I think so. Is there a specific reason that people don't have the untrusted model adversarially try to 6 versus 6, 3 versus 3?
Yeah, I think it's just it hasn't been done yet. I think that's a good idea. Yeah, having multiple things going on here, and we'll go into another idea that I think is promising, which is called debate. So you can imagine GPT-3 and GPT-4 debating with each other, and you can even imagine a team of debaters. So GPT-4 is trying to make the case to GPT-3 that this is safe code, it needs to get through, whatever. GPT-3 is saying, no, you need to rewrite this code to be more readable. It looks kind of sketchy. I think there might be an exploit in here. And you can imagine them going back and forth until some threshold is met by GPT-3 that says, okay, this code is good, let's go. So I'm going to continue. All right, so another method that I think is promising is called interpretability. If you've heard of mechanistic interpretability, the whole idea is that we have these giant models. I think a key part that a lot of people don't really understand about these models is no one knows how these work. Like, as I said with the thing about like just search and learning's all that scales, you throw a bunch of compute at this thing, you get out a model, trillion numbers, have no idea what these trillion numbers do, they just work. They happen to do the right thing. We have like some ideas of certain things, but like a big push in AI safety is trying to understand what these models are doing. So we can see like, oh wait, is it trying to deceive me right now? Is this deception sensor turning on or something? And this was like, has been a rather hard problem. There's reasons to think that this is going to get better. So actually 2 days ago, Anthropic, which is another AGI lab, released research where they tried to say it bluntly or easily, they were able to look at all the weights of the models and try to find certain features that only fired when certain things we're talking about. So, and then they can manipulate these features. So a good example of this is they found a feature that only activated when we were talking about the Golden Gate Bridge. So whenever the Golden Gate Bridge was coming on, a set of these 30 neurons were lighting up, and they were able to detect this and then actually be able to manipulate this. So they got it to where they could ask the model, who are you, Claude? And then it said, I am the Golden Gate Bridge. I really like being a big structure or something, and this kind of implies that if we are able to, we can find these features. Some other features are this is a coding error feature or a gender bias awareness feature. So these are more abstract things that we can start to discern in the model and see when these things are turning on and turning off. And if you think about it, if I'm able to, if you're trying to deceive me, but I have full access to your brain and all the concepts you're thinking about, this is a much harder problem. I don't know if this scales well, but it is promising research to look into this kind of stuff. All right, next slide. It's called multi-agents. This is another cool idea that I think will work rather well. We all know what companies are. Companies are pretty effective. Some people would say companies are more intelligent and more capable than an individual. We have a lot of strategies of organizing people together such that they are doing something greater than the sum of their parts. And this is really cool that we can organize humans like this. Why can't we apply the same things to AIs? So we take a bunch of GPT-4s, they're kind of dumber than us, but maybe if you organize them in a good way into some software engineering company, they can output good code. And they have all these processes where the code goes to the QA engineer, and the QA engineer throws it back. And then you have a PM that's talking to the customer. They're all small, toy examples of this. But this is a good way to scale intelligence. And this is an empirical result called the Chat Dev paper where they did exactly this. They made a small company. There were 4 developers, 4 designers, 4 QA engineers, and a CTO and a CEO. And they had this whole design scheme where they would write specs, and then the CEO would look at them and blah, blah, blah. They would all code. They would talk about it, go back and forth. And they were able to output rather decent code. So this is a promising example of how we can have dumber things automating together to do smarter things. And all we need to do is figure out the correct way to organize them in a company-like structure. And importantly, we don't think that these things are smart enough to take over the world. So we can still get useful work out of this. We can still get AGI level things out of this without exploiting, just using the really smart model that no one knows what's happening. And we can monitor all their communications, do the same kind of untrusted, trusted thing that we were talking about, and get some good work. So this is a promising example. And I think that this kind of might be what the world's like in the future. I'll have an agent, you'll have an AI agent. Our agents will talk to each other, get some stuff done with each other, and we can trust them. All right, next strategy is called how to build AGI, factored cognition. So this is another interesting idea that the whole point is that you can break up tasks. It's similar to the company, but you can break up tasks such that you can do each task in 15 minutes. So an example is let's say I give you 15 minutes to solve some crazy differential equation. Maybe you can't do that, but imagine that you could defer to a copy of yourself that had like 15 minutes of like subjective time or something, but it was able to spend those 15 minutes doing whatever and report back the result to you immediately. And then you have like a bunch of copies of this. And each one of these things has a copy of you again that you can like defer to and get something done. So it's like, is it possible to take these complicated tasks and break them up such that a copy of you can do a lot of these? And obviously what you do after this is you train a copy of you, something that inherently you trust because it's kind of like acts like you and is trying to act like you. And then you can get a giant iterative amplification power of your intelligence just by like talking to this machine. It would go and do everything that you would do, but it's like basically you get to spend like 100 years on a task in like 15 minutes because you have a lot of copies of yourself. And inherently we trust this thing too. It is you. It is not smart enough in these 15 minutes to devise a plan to take over the world. Its context is cleared after each time. There's still some scary parts about this because like maybe we don't trust you completely or something, but I think this is a great idea. Another great idea of how we can build these intelligences in a useful way. All right, so this is about it. I'm gonna go over a conclusion, and so in conclusion, AGI might be near. Like my current estimate is 3 to 10 years. I think that we will have these kind of systems that are in our economy working with us. Maybe it doesn't replace all humans, but it's gonna replace a good chunk of types of jobs that are, do not require significant cognitive labor. Making safe AGI is very hard. Because like, especially with all the market incentives, people do not want to, but they need to. And like, at the point that it matters, it's gonna be to the point where like, you can't tell, it's hiding its deception from you or whatever. But it seems possible that we can do this. And yeah, as I said, making people use the safety techniques is the hardest part. I think this is like where most of the time needs to be spent now, because I think we have, if given 100 years, I do not think this will be a problem, but we seem to have 3 to 10 years to solve this problem. So I think like forcing people to use them is the thing that we need to work on the most right now. But yeah, that's the end of my talk. I would love to take some questions about this. Yeah. All right, I've heard.
You mentioned the example of Claude with the bridge, taking the idea of a bridge and thinking that it was a bridge. And also, well, my point is, what do you think about hallucinations?
About hallucinations?
Security and all of that.
Claude, the question was like, Claude's like making talk to itself like it was a bridge and like claimed that it was a bridge, and how does this relate to like hallucinations? I do not think hallucinations are going to be that big of a problem, and like as time goes on, it seems like we've been getting better at this, which is like good. The trend is upwards. Something to like say a hallucination is kind of because we're training these systems to say the thing the human wants, not the truth. And like it's very hard to train a system to output the truth because like, sometimes we don't even know the truth, and it's like very hard to like discern this. So like a hallucination, I think is going to in the future look like these things trying to say something to please you, even though they know the truth. They're not going to tell you the truth because like that's not how they were trained to work. But yeah, like as these models get better, I think hallucinations are going to go down. Just like as humans get smarter, we stop saying dumb things theoretically, So I think that that will be solved eventually. I mean, it's already slightly better right now with GPT-4. Yeah.
So in your diagram where you had that one for that one.
Yeah.
How much computation power is required in order to run that? Because that seems like you have a lot of agents, a lot running. That seems like a lot of power.
Yeah, it probably is. This like is like one of the downsides of, so like there's this thing called the alignment tax. It's kind of like the tax that one pays to have aligned models that are like on your side doing the right thing. And it's like, they will require more computation. They will be slower, but like that's what we have to do. You can try to optimize for methods that use slightly less computation. And it's harder because it might not be harder. This just in this example, it is like they pay a high alignment tax for good results. This is like one of the hard problems with this industry as a whole is like people don't want to pay an alignment tax. They're just going to train the big model, deploy it, and that's night out.
So my question was that we know both pros and cons of things, and there are certain things that we like. Everything has some limitations. So we all know about the Sophia robot. There was an interview, and it literally said on face that someday its ultimate goal is to kill humans, and we know that there are certain things that we need not to take risk, because I feel like advancement is good, but like going into like more and more, it's just self-harming ourselves. Even we know that. So there are certain things that just need to be done by humans, not being like very dependent on the technology, because end of the day it just will harm us. As we know all these things gonna happen, taking that risk is just like, as we see so many species in this earth as being extinct now, and some fine day even we will be, and everybody knows that. And I feel like this is not the right way to do it, or because we know we are not going to be alive someday, and we should take some other ideas or something, but not being this much advanced to kill ourselves.
Yeah,
So-
yeah. I completely agree with you said. Yes, there are definitely things that humans should not do. And I kind of agree. I don't think we should be doing this, but like we can't stop ourselves. And
How
like this
can
is like
we
yeah.
advocate this? Like,
How can we what? Sorry?
Like, how can we advocate this case? Because this is not just about a single person, but this is about this whole world, the
Yeah,
globe.
yeah, that's
So,
why, yeah.
this is not a easy or simple thing, because it's pretty serious.
Yeah.
As we progressing in these things, I feel like we need to advocate about these things. Of course, there are people, as we saw coronavirus as well, everybody knows it was from China. Was it intentional or not? 50% I think it's intentional.
Yeah.
We still think it's not. So these things gonna happen, but we need to stop this, as we know, because there are so many examples how human knew what was gonna happen, but
Yeah.
still we did it, being a over smart person,
Yeah, yeah.
just like world wars and stuff. So this is something we need to stop. I
Yeah,
feel,
yeah.
and so if that is the thing, then why are we like thinking more about it? Because
yeah.
it's hard. Gonna
So
harm.
yeah, I have a couple things to say to that. I completely agree. This is probably a bad thing to do. But like there are a lot of things that is a bad thing to do, but like humans are still doing it anyway. Like like climate change, like we're still like polluting the earth. We're still like doing just like terrible things all the time. And like I think that you can like weigh these things. Like my metric that I'm like judging based on like what I work on with my time is like what prevents humans from not being around in 30 years. Like I want humanity to like expand, go across the whole galaxy, take over stars, have a great time. And this to me, I put the highest probability of ending that. So like that is why I am trying to work on this right now. And like like climate change, I put like a slightly lower probability, asteroid hitting us, much lower probability, things like this. This seems to be the most important issue facing us. Now, the issue is, yes, if I was the president of the world and I could control every single person's actions, then I'd say don't build this until we figure it out all the way. But I'm not the president of the world. And like, so my best strategy of doing this is telling other people about the issue. And like, hopefully, if you think this is about like a scary issue, you go out and like tell your friends, call your congressman, like, try to like prevent this from happening. Because yeah, this is like even like if everyone in this room is like, yeah, this is bad, doesn't matter because Sam Altman and like, OpenAI are still going to do this. You could give this presentation to the whole world probably, and like people wouldn't care, because like there's money on the line. So yeah, cool. I saw a question back there.
So I think the question she was asking is about like harm reduction, right? The harm is already there. So like, how do we reduce it? And so everyone in this room kind of has that responsibility to move forward with this, like a security mindset, which I guess, I'm the hammer, that's my nail. But like, how do you, in the position you're currently in, ensure that you guys are like working from that position first, like making sure there are checks in place and things like that. And so there's all our, like we can all do our part, right?
Yeah.
Anyways, that's what I got.
Yeah. I think that's a very important thing. Like one of my goals is to like eventually make it into one of these companies and like advocate from the inside, because I think that's one of the best places to be. Yeah, I saw a question right there, and I'll get to you next.
kind of the tenets of the paper is the sheer amount of data that you have to throw at any of our generative AI models right now is
A lot, yeah.
Basically, your return is logarithmic, in that you're going to hit this max, and the amount of data you have to throw at it is prohibitive. And they've done surveys where they've gone out and
This is log scale. Yeah, you're right.
grab the data, the stuff that's there, and you couple that with the fact that it was Microsoft that now are spending 30% more in energy just because of their AI efforts.
Yeah.
And I mean, it's mathematically it might not be reasonable to use.
So yeah, I think I see what you're pointing at. You're like saying, yeah, like, well, it is possible, but it's going to take too much money. I say no because humans are an example. Like we somehow are able to take enough data in our lifetime to do it. It does not cost $10 billion to raise me. And I think that just means that our algorithms are inefficient. And as we look over time, things are getting more data efficient. Things are getting more sample efficient. And yeah, so maybe it doesn't reach it. It is a log scale. Maybe it doesn't reach it. But like, let's say it takes $100 trillion to build the AGI that kills us all. I think that might be possible. $100 quadrillion, maybe that doesn't. And no one knows what the number is. So we're just like kind of throwing around numbers. So it could be 100 billion, it could be a trillion, it could be 100 trillion. We don't know. But like, I bet it's lower than 100 trillion, and I think that's possible in the next 10 years or something, or not 10 years, but like maybe next 2 decades, we'd be able to do that. So it's just like the probability game. What are you going to play? Like, it is definitely getting better. We are possible, and the amount of cost might be enough where it is possible to happen.
But actually, that's really not the case, because I mean, if you take even an example of a baby learning to walk, a baby is not going to take, the mind is not working as a computer. It is clearly the case. Just for the amount of data that's necessary to come in for a baby to learn how to walk versus you're going to train something to recognize cat pictures.
Yeah.
I mean, it's radically different. So your assumption that the mind is working exactly as these AI systems are, that's...
Yeah, I don't think it's working exactly at all. Like, yeah, I totally agree. It's not working like the mind. But we have more money to throw at it than evolution did. So like, it seems like, yes, there are 2 possible ways we get to AGI. I.e., we like figure out how the mind works and make our systems more like that, or we scale up our current systems and they happen to work. And like, I think that it's like both of these strategies are happening at the same time. And the question is, when does this convergence point happen? Like, where we're more like the mind and like it costs less. And I would assume that this convergence point happens sooner rather than like never. But yeah, I think those are good points to consider though. Yeah, I think there was some questions back there. I'm sorry. Yeah.
Yeah,
sure.
it's not really a question. Kind of like just restating and reaffirming what you said. To go back to her question / statement, I completely agree with you. I think it's inevitable. It may not be the current set of algorithms, and it may be something that right now looks to us to be some unimaginable amount of compute that's required. It may be 30 years, it may be 40 years, it may be 10 years. We don't know. This is probably going to happen.
Yes.
And again, if you were president of the world, if I was president of the world, I'd say, let's slow down and figure it out so that it doesn't happen wrong. And as a society, back to her thing, as a society, it may overall be bad. It may overall be the bad thing to do. But each individual organization, it's the right thing to do. They're financially incentivized to do it.
Yeah.
Because, like you said, the first one that gets it is going to be the most powerful organization on the planet, basically.
Yeah.
And so there's this huge incentive to do it because you don't want to be the one that didn't.
Yeah. Yeah, I agree. I think that, well said. Yeah, green shirt. Yeah.
Without thinking of like a fantasy scenario, I'm having a tough time understanding how artificial intelligence would exist if there was no human intervention whatsoever. Like there's no humans at all, and you could say, all right, well they need power, they need resources for this, they need to do this, and so I just feel like eventually we kind of end up with, okay, actually I do need human intervention, so killing all humans wouldn't be bad.
Yeah. I guess the question is, how many AIs does it take to keep the Hoover Dam on? And like robotics tech is advancing rather quickly. Like once robotics reaches the humanoid level, I think it's not a question anymore. Like you need like someone keeping the factories on. You're right. You could also imagine a situation where it's not necessary, like the AI can take over the world and use the humans until it doesn't need them anymore. Like this isn't like, there are like a lot of different scenarios you could make about this. But yeah, I think this is a reason to like think that it's not going to happen right now, unless this AI has a strategy, where it can figure out how to do all this without us. It's unclear to me if we're actually necessary, or if these things can self-propagate across all the servers and like figure it all out. Like it's just like an unclear question. I think more research is needed there, but I think that's a good thing to point out. Yeah.
Do we have enough human data to train the AGI, or does it matter at all? Because at some point we're going to run out of it, and we're going to use AI-generated data to train AI.
Yeah. I don't think it matters that much. I mean, like we use human-generated data to train humans, and like I don't see any reason. Like self-play. For example, the Go playing bot made by AlphaGo, they wrote a simulator to play Go, and they just let it play with itself for a very long time, or like used a lot of computation, and it got superhuman at playing Go. I don't imagine, I think that an AGI that can just kind of manipulate the world a bit, or like play, like self-play is what it's called, would be enough. And it's also not clear to me, GPT-5 is being trained on like AI-generated data. Actually, I do not know this is a confident claim, but there are definitely models that are good that are trained on AI-generated data, and this does not seem like a problem, but it might be eventually. So yeah, jury's out. Yeah. Jack, did you have a question? Yeah. Okay. Yeah. Any other questions? All right. Okay. Well, I'm Tyler. Let's see. I'll go to the end. So yeah, this is my contact. You can find me at tylertracy.com, x.com/tylertracy321, or that's my Gmail. If you want to talk about this, I love talking about this. As I said, I think this is the most important thing facing humanity right now. If I had my way, 30,000 times more people would be working on this, but they're not. So if you want to consider what you can do, come talk to me. I have a lot of different ways that you could get into this and help. Thank you all very much.
All right. Thank you, everyone. That's the first half of our day today. We're going to have a break for about an hour until 1. If you want to go find some lunch, we have some snacks back there. Probably aren't enough for everyone. We may have some content during this lunch break, but otherwise, feel free to wander. It's a nice day out. Maybe worth a nice walk while you have the time.